Thank you. Thank you for welcoming me on stage, but you should get an extra applause for that really nice talk. So, my name is Clemens. I'm here on the weekend, which means I'm not working, like you are not. And so I'm bringing a talk that is a little bit about the Microsoft stuff towards the end, but kind of in the vein of what you just spoke about. I will not speak about the singularity and how that's going to kill us all. Um, See, when I was young, when I was very young, people walked the moon and flew across the Atlantic in 3 hours. Um, Today, not so much. um, I like big things. So I want to talk about some big things. I don't want to talk about the Raspberry Pis and the Arduinos and the smart home. We'll get to those later today. I want to talk about bigger things, and I'm kind of the geeks. I'm probably the only one who has a 747 sticker on his laptop. I like bigger things and bigger infrastructure. We're building stuff for bigger infrastructure. And I want to go and talk some of the things that I've been seeing over time as we were exploring the Internet of Things, and kind of which led to us building the IoT hub and the IoT suite that we presented at the Azure Con 2 weeks ago. So I want to talk about stories, and then in the end, I'm actually going to talk about what we built because of it. This is fantastic. I'm not going to turn those off. I think it's going to be fun. So yeah, and you should really follow me on Twitter. Do it now. Yay! See, this is wonderful. This is working. So I'm going to leave those on. Be well behaved though, because you're going to be on video, and it's going to be your name on there. So mind that. See? Fabulous. I love that. So this talk is about that. I have a ton of slides, and I hope I'm going to get through them. Things, homes, cars, machines, factories, streets, and the internet. The Internet of Things, so here's a text slide, I'm sorry, but I had to go and lead with that one. The Internet of Things is full of opportunities, and what you'll see here is you don't see social, you don't see, the common, like smart home, you don't see any of those things here. It's very boring stuff here. Process optimization, energy management, environmental protection, security, safety. Because in my experience and having talked to people about this whole area for the last 2 years, I believe that's where the money is. And knowing where the money is important if you are running your own business or if you work in consulting, and if you work, so if we're all going to be confronted in some way with the Internet of Things, even just learning about the hype. And it's going to be very interesting to see where the actual opportunities are, because I believe that they're not in building little blinking LED lights with Arduinos. I believe that they're in building large-scale infrastructure, and I'm a distributed systems guy, and I'm really excited about the opportunities because they're really large, interesting distributed systems opportunities, but also opportunities that have to do with having computers interface with the physical world. So we're going to start with a Volkswagen Diesel. We're going to get to that topic too. So this is a highly automated driving car from IAV Automotive Engineering. That's a company that we work with. And IAV Automotive Engineering is a company that is bringing you, if you happen to drive a German car, not only Volkswagen or Audi, but also others, they are doing active safety systems. Active safety systems is, for instance, the distance radar you can buy for your car that kind of keeps you at the same safe distance, or systems that will go and slam on the brakes for you if you're not looking. These are active safety systems, and those guys are building those, for instance. So this car here is a stock, very normal Volkswagen Golf, and it has two things of note. It has a radar that's here, and that's a normal radar that's kind of for the distance sensor. And just if you look at the windshield, up on the windshield, there's a little camera. And those cameras are now very commonplace. If you look at new cars, many of them have those cameras built in. Sometimes they're not even active because they're cheaper to build in without you actually going and activating them. But these are stock capabilities that are in that car. So now I'm going to do something. I'm going to take you on a drive with Lars. because we had Lars and colleagues from IAV out in the US with their US-based car. And what you're seeing here is Lars driving, and now he's has his hands off the wheel, and he's just setting the speed that he wants to go. So now he's got his hands off, because that car is now driving by itself. So this is an autonomous car, and that autonomous car is not using a map. That is the difference between what they do and what the Googles do. The Google guys are relying on a perfect map of the world that the cars are following, plus assistance through sensors that are helping. This car here is observing the road and is kind of observing the lane markings. And what you can see in the middle here, in the middle display, which is going to zoom in a second, you can see that where the lanes are, and you can also see that there's an arrow pointing. This was a little dirty, as you can tell. So this now says, hey, you could go and turn, you could switch the lanes. The car doesn't switch the lanes by itself, because you might know this when you are driving the highway, specifically in Germany. That's a huge problem. You look into the mirror, and there's a little black spot that becomes very big, very fast. And that's a Porsche that's just jamming by you like 210 kilometers per hour. If that happens to you and you turn into that, not a good idea. There's no sensor technology yet that's as good as the human eye to actually go and make that decision. So here they're playing this safe. What's important here is that this is happening with current technology. Now, the car is braking all by itself, following that car. He's not doing anything. He's gonna adjust the speed briefly. And I was sitting in the back, and I was creating this video, and this is the situation is like you are following, like you're sitting on the side, on the passenger side of the car, and there's a driver, and you don't quite trust that driver. It's horrifying when you sit there and you know that the computer is driving. And so this is all the computer is just doing it. And so this is the Americans are driving really crazy. Look at that truck. He just wants to go and go past all of that traffic, so he's just blinking, and he just wants to go in, so the car stops behind him. And now some idiot actually lets him in. So that's a highly automated driving experience as it is currently. This is going to ship within the next year or two. You're going to see the first incarnations of, I can go and take the hands off the steering wheel. That is not yet fully autonomous driving. Fully autonomous driving is something that's going to work when the insurances tell us we can. I'll get back to fully autonomous driving in a little while. But I talked about Volkswagen Diesel, so let's go and talk about pollution first. Are you familiar with this? Does anybody know what that is? A few people who are in Germany. So in Germany, we have a law that requires you to have stickers, these round stickers, in the side of the windshield. They're green or yellow or red. Red is if the emissions are too high. Green is if the emissions are a certain limit. And in certain cities, especially in my state, I live over there in Mönchengladbach, close to Mönchengladbach, which is close to Düsseldorf, Cologne. We have these cities which have these zones, and you can't drive into that zone with a car. And the reason for that is air quality. The EU is mandating certain air quality levels in cities, and the only way we can make that happen in our region, because we're heavily industrial, is by regulating which cars are going to go to those zones. And the way how this is, and some of those zones are even dynamic. So during certain times of high pollution, we're effectively saying you can only drive in the city if you have the green label. How is that being measured? Well, there's these somewhat run down, in this case, measuring stations. So what we have in the cities, and as we're adding monitoring around the world for air quality because we want to keep the air breathable, we're creating these networks of sensors which are just managing air quality for us. That is the Internet of Things, right? We're monitoring air quality. That's something that is really important, and there's a project we have projects we have in several places, Microsoft Research, for instance, city noise. So noise is also a form of pollution. So there's a project we have for Microsoft Research for the New York City 311 platform, and that is measuring noise pollution. In Beijing, we have a project that's called Urban Air, and Urban Air gives you air quality monitoring in Beijing. So if I go and click this, and the network collaborates with me, it does. So here's Beijing, and Beijing right now is doing pretty well on air. Depends on the time of day and what day it is. Now it's the weekend. During the week, this can be bright red, and air quality can be horrible. Today is a good day in Beijing, apparently. So this is live data collected from Beijing and then put on that map to help people monitoring kind of what the air quality is in all those different places. That is the Internet of Things in a very practical way, bringing all that sensor data together and then evaluating it so that you can go and take controlling measures. For instance, kicking out all the cars that are not fulfilling certain levels, certain standard levels, so you can go and improve the air quality. Or as other places do, only the cars with registration license plates with even numbers can go and drive. Right? The Chinese do that, the Greeks do that. So that's something that you can take in terms of measure. This is the Internet of Things in action. Let's get back to the autonomous car. The autonomous car can be good, like Herbie. That was truly it's truly a good autonomous car. Yeah, the autonomous car is already here in the movies and has been for years. Or maybe not so good. Anybody know Christine? That was not such a good autonomous car. What's going to be interesting in terms of autonomous driving is that that it has the potential to really change the world and literally change the world, and has a lot of potential. I'm just going to keep that slide up while I'll talk about it, because it kind of lets you imagine how that all works. So right now, the people in the car industry are projecting there's a 10-year horizon for us to get to truly autonomous driving. What you just saw earlier is where we're going to be in about 2 years, in a year or two, depending on who the vendor is. So the capability you will be able to buy is that you can take your hands off the steering wheel and the car is going to drive for you in most situations. But you have to be alert. So you're driving. So all of the autonomous. Daimler had just a huge press release. Yeah, we had the first truck that drove on the German highway autonomously. What you need to note is, like, if you see the videos, there's always a driver behind it, and then the car is doing itself. Because what the logic does that sits in those cars, it's going to give control back to you if it doesn't know what to do. And right now, the systems know very often not what to do. Because the sensor technology is just not good enough. The data is just not good enough. So there's something that is required here to make that better. I'll get to that in a second. In 5 years, it's believed that the car can warn you, can handle most of the events that are happening, and it can go and warn you about 15 seconds ahead of time, which means the cars can deal with everything in urban traffic. The cars can deal with everything on the highway, but the cars will know that there's areas where they don't know. But if they drive towards them, they will give you 15 seconds of warning, and then you take control over. Which means at that point, in 5 years, you'll be able to go and watch a movie in the dashboard of your car. You still have to sit there, and then the car will go and give you an alert and say, hey, you got to go and pay attention, and then you can take over control. It is believed that it's going to take 10 years for you being able to turn the back to the street. And then comes psychology. Like, that's the technology roadmap. Are we all going to do it? Are we going to buy a car and then sit with the back towards the street? And I'm not so sure about that. I'm not so sure about whether it's then really attractive to actually have a car. What's interesting is that this capability that is 10 years out by current projections is going to fundamentally change how cars are being bought and how cars are being used. Because there's a lot of people who obviously don't care about having a car. They just have a car because they have to. So you see those, the people are driving super old cars, people are buying Toyota Corollas. They obviously don't care about the car. So we're going to have, especially in urban areas, the world will change very dramatically. Because if you can go and take your phone or whatever device is going to be there in 10 years, and you can just summon a vehicle to you and that's going to be there in a minute, why buy a car? So you just sit into a little cabin, and the cabin is going to drive you across town, and then you get out and the cabin whisks away. That's fine for me. It's the new bus system. Buses will go away because there's no point in if you can go and do those things point to point, electric, there's no point in driving these 50 people things around half empty, but you can go and make it much more efficient. So I think autonomous cars might just quite well be the future of public transport, eliminating the need for a lot of individual vehicles, which means getting into the business of building autonomous vehicles just now is going to be interesting in how that works out economically. I think the high end where the money is being made is still going to be in driven cars, because people who like driving will want to keep driving. And the autonomous cars are really, that's the future public transport. I think that's where it goes. Now, let's talk about what it's required to get there in 10 years. What's required to get there in 10 years, to make this work, that there's all of those cars, the autonomous cars whisking around, is that you are adaptable to the changes that are happening in this landscape. Accidents, construction sites. You can't make a perfect map that's accurate enough for driving, because there's always something happening in the street that is an obstruction. It's really hard, for instance, to go and figure out, what is now you have a sudden lane closure because there's an accident and now the road is being closed. Your map in the car doesn't know that. If you're entirely just relying on the map in your car to go and do autonomous driving, that will not work. If you have a new sign put up, so there's a construction site here somewhere, and there's a new sign put up, speed limit 30. And they put this up in the fog early in the morning when it's dark. And your car drives by there, your autonomous car drives by there. Well, it needs to have a digital signal, that sign, or it needs to read it with optics and do recognition. How accurate is that recognition? 100% no. So we'll have to have crowdsourcing, so where the cars are actually doing sensor fusion across each other. So they have to go and take their observations and put them into a system that sits on the side of the road that can then be shared with other cars. So all of a sudden we have the need for distributed systems which are deployed throughout the infrastructure in cities. Will cities pay for this? Yes, they will. And they will because this is all about safety. The entire motivation, and this is why the active safety people, that video that I showed you, Lars is working on active safety. That's why the active safety people are working on this, is because people pay for safety. Nobody pays for points of interest and sports news in your car. Nobody. Well, you pay a little bit. So I just ordered a brand new wonderful Audi, and for those services, for everything from current events to parking information, I pay 500 euros flat. That's for the lifetime of the vehicle. There's no money in there. And I find 500 euros already very steep. But at the same time, I'm buying active safety systems for much more than that, because that's something that I find there's value in there. Investments in infrastructure is being made if we have fewer cars running over kids. That's something you could sell politically. And the vision that the automotive industry has and that the insurances have and also that the cities have is that we get to 0 traffic deaths by 2030. 0. Because the infrastructure is smart enough. And that's what pays for all of this. Autonomous driving, automated driving, all those things are being driven by just one thing, safety. And not convenience or any of those things. The money is being created because of safety. And that's actually true for a lot of those things. It's for convenience is one aspect, but not killing people while we're moving around, that's actually a big plus, and that's what people are willing to pay money for. So more examples of stuff that already exists. So there's traffic management in Düsseldorf, for instance, one city. They have the traffic situation, the construction sites, the current, and the forecast. So this is accurate on a daily basis. So you can look this up, and you can go and get that data in raw form. So you can do planning. If you're driving around in Düsseldorf in the city, you can have an accurate picture of all the construction sites that are happening in town and augment your maps with that. Special events. So they have in their database, they know exactly when there's a soccer match. Sorry, I'm not in America. A football match. Borussia Mönchengladbach. Football. So current events, when there's a big concert somewhere in a concert hall, they have that on there. And they have a projection what that will mean in terms of traffic impact. So the city of Düsseldorf is already doing a lot of work to kind of allow prediction of how traffic is going to be. And if you are delivering postal goods, you can go and build your systems based on that database to make sure that you can go and avoid those things, or you can go and schedule around them. So the data is there. Seattle and some other cities, there's a crowd-driven program called One Bus Away, which is done by the University of Washington, University of South Florida, and Georgia Tech together, because in America, the public transport systems are unfortunately really deeply underfunded. And so they have built this absolutely fantastic system which gives you real-time predictions for when buses arrive, when buses will leave, which buses are late. One Bus Away is a fantastic thing if you're in Seattle or around there. And it's a consortium that's helping kind of from the research side because the public transport authorities just can't do it themselves. But every single bus has sensors on them, GPS sensors, and kind of send information out, and then that data is being collected and is being put onto a public map. So on that map, you can actually see where the bus is right now. It's also very interesting traffic information that you can use if you want to use public transport to get around. You can use that for planning. And they're also making the data available again. So you could write a program on top of that platform. All of those public transport things are going to be really lit up by electric vehicles. And I'm taking the Tesla here because that's everybody's favorite electric vehicle. What does e-mobility really mean? E-mobility has significant impact. And can everybody? So let's go back. Many of those things, many of those visions of having these autonomous cars will not happen because they're relatively far out in the future, will not happen with fossil fuels. Because it's infeasible that we're going to go and add so much new investments and also municipal investments while burning fossil fuels, because that will be against the political will. So we're going to have a lot more e-mobility because it's a political issue to get to zero safety, but it's also a political issue to get to fewer emissions. That all belongs together. We're doing all that management. We want to get to e-mobility. So e-mobility here is a big driver. E-mobility has a lot of problems. The Tesla is a great example of some of those kinds of problems. If you are calculating what energy is contained in a liter of diesel or a liter of normal gasoline, the energy that's contained in there, and you calculate how much is typically in a tank of gas in a car, and you think about how many cars are in a city, and now you compare this to the capacity of the electric grid that exists today, it's not even close. It's impossible for everybody to buy a Tesla and just drive, because the system would completely collapse even when we reach, not even when we reach a fifth or a sixth. It's impossible today for everybody to drive an electric car, because we wouldn't have any way to charge them. There's no transfer capacity for all of that energy, because fossil fuels are enormously potent in energy. So we'll have to do something about this. We have to go and do renewables. We have to bring the power generation closer. We have to do a lot of work to go and make that all happen. And also that requires coordination. I'm still talking about the Internet of Things here. Renewables. Renewables is where we're all going to go. California just yesterday put into law 50% of all energy needs to be generated in 2030 by renewables. In some countries in Europe, we're already there. Scandinavia is pretty good in doing on hydroelectric, obviously. And in Germany, we have all those windmills. These are not in Germany. I think these are in Denmark. But we're doing much, much better on wind generation and harvesting power from renewables. That has some consequences, though, because this is not a steady source. For an energy company that generates power and an energy company that transports power, these are separate, that is a wholly new set of challenges, which I'm going to illustrate to you showing a slide of stats from ENSO-E in a moment. So we have solar and wind as the two viable, reliable sources of energy that we can go and use. Now, solar has some really interesting problems that you will not think about. And as soon as I put that, now that's the next slide up, you're going to be, whoa, yeah, I didn't think of that. This is the real data. So the most recent solar eclipse in Europe caused a 30% drop. Well, actually, no, a 50% drop in capacity in Central Europe. Now, think about how power transfer works. Power transfer works with, we express things with voltage, right? And what is voltage? Voltage is tension. So there's got to be a lot of power here that kind of flows in one direction. That's kind of how that works. The power grid needs to be in balance, and if the capacity, the available power generated from wind, impacted by solar, and power from solar drops, you have to go and replenish that. You have to go and push the same power in, because there's still people drawing power in the same rate. So the upper bar is the draw out of the consumers of how much power they needed, and the solar eclipse kind of caused a 70 gigawatt drop and deficit. So what you really need to think about is, and what they really need to think about is, now they need to have fossil fuel plants and nuclear plants all across Europe, because this is something you can't deal with in a single country fashion, all across Europe, and that's a coordinated effort to kind of power them up and bring them up in a coordinated fashion so that they can go and fill that hole. Because the only way you can fill that hole in that solar eclipse is by fossil fuels and nuclear. Interesting prediction that comes with that. Between now and 2025, we're going to lose 60% of our fossil fuel capacity, fossil fueled power plant capacity. This is going to be a huge puzzle. The next solar eclipse, right? As we're nearing that, it's going to be a huge puzzle. So how does that work? Tighter coordination. They're building better networks. They're coordinating that better. What needs to happen is that every single power source, and we're not talking about a dozen power plants anymore in a country. We're now talking about every farmer puts up some wind generators, all of those need to be connected and they all need to be coordinated. It's a fully integrated network of energy sources, and that's the only way how you can go and deal with those events, because you really have to have that data and you have to have it in real time. It's pretty amazing. We're very happy that we got through this without outages all across Europe, because this is something, a solar eclipse is something you could see in advance. So one of the ways of how to deal with that is obviously hydroelectric, and that's what people are looking at, because you could say, well, let's build some new nuclear plants. That's not going to happen. Or let's keep all the coal plants around. People are not going to go and like that either as an alternative. And having a coal plant sitting around dead is not a great option. So hydroelectric, this is one of the first examples of that Köpfchenwerk in Germany, built in the 1930s, still operating. What they do here is there's a lake on top of that hill, and now wind energy is used to go and drive those pumps, and the wind energy is pumping the water up. And when you need to have extra power capacity, the water is then going to come down and drive generators, and so you can go and now you could store wind power, and you can store solar power by just pumping stuff up the hill, and then the power is being generated as the water comes back down. It's a battery. And so we'll need more of this to deal with our network. And again, it requires coordination, because if we're depending on renewables, we're depending on the wind, we're depending on how much storm there is, or if there's nothing. So it's going to be an interesting world that we're going into, and it's only possible because of networking. Only possible because we inter-network all those things. ENTSO-E, who I got this from, have a transparency website. Generation, load, transmission, balancing, outages, congestion management is all available from transparency.entsoe.eu. ENTSO-E is the organization that is the coordination body in Europe between all the energy grid operators. So they're putting up this website, and you can go and look at all the data of how energy flows and is transferred between the different countries in Europe, which I find rather interesting. So that's all digital now. Then there's this very interesting space of industrial automation, which also benefits from the Internet of Things in terms of optimization. The industrial folks have been some of the first who are leveraging digital technology kind of in an Internet of Things way. And if you go and talk to industrial automation folks, as I do, I'm a member of the OPC Foundation's Technical Advisory Council. The OPC Foundation defines a set of standards to go and coordinate communication between industrial devices, sensors, process controllers, and robots, etc. They've been some of the first. In the late 60s, the first digital controllers emerged, and it has been an evolution since then. So if you go to industrial automation folks and say, "Here's the Internet of Things, here's my Arduino," they all laugh you out of the hall. But for them now, the challenge is to come out of the box. So one of those machines, which is doing real-time communication, digital communication, and go and hook this up to the rest of the world. One big topic in that space is, for instance, remote monitoring. So you have a factory that sits somewhere in China. No, your customer has a factory that sits somewhere in China, and you're selling them equipment. This is big in Sweden. This is big in Germany. This is why also, it turns out I haven't been much to Sweden until like 2 years ago, and now I feel like I'm here every third week. And it is because you guys are doing cars, and you're doing industrial machinery, and you're doing that really well. And Germany is doing cars and industrial machinery, and we're also doing that really well. But we're the two places who are doing that really well, and then the rest is just copying us, right? So you sell a machine into China, and now something breaks on that machine. It's really more efficient to go and take a look at that machine remotely than to send someone to fly to China to see that someone flipped the switch wrong. So that's one trend that they want to do, but really also like having integrated plant monitoring, also integrated flow of data between the production line and the ERP system, like really making this part of integration that we know as IT people is something that's the hot topic. That's what it's called Industry 4.0 in Germany, or the industrial internet. That's the current trend there. This is all about process optimization, saving money and making the process more efficient. That's happening here. So the Internet of Things, in the sense that the hype talks about, has been happening in the industrial automation for 40 years. But now they're looking into having a convergence of their world of Internet of Things, the operational technology, with IT technology. There's another field of automation is home automation. Here's an aging Honeywell thermostat. And the Honeywell thermostats are just an example here, and they could be from anybody. And they're just standing for just home automation and home optimization. And how much will that be a field of, a money source for people? If you look across the Internet of Things startup space, smart home is what everybody seems to be doing. Because it's cool. But is there money in there? And I have to say for myself, I'm not sure I would buy any of that stuff. I'm not sure I care about walking into the house. I really care about walking into the house and say, make the living room 2 degrees warmer. Cortana. I don't know how much where I really, really care about this, because right now I have these little boxes on my window blinds, and they go up and they go down, and there's a little thing that is sensible to where I live and kind of adjust it for time. It's good enough. I don't think I have to go and control that over my smartphone. There's a lot of stuff that's being done there in the Internet of Things, which is interesting, but only like for 3 moments, and then I'm kind of, really? Do I really need that? I don't think that's going to drive much. Like, yeah, people are buying this, but the geeks are buying this. But will your mom, your wife, your husband, if you're the geekette, will they care? I don't know. I could tell you someone who cares, though, but they don't care about this. They care about something else. And now notice you may know an Internet of Things company that you heard about that's doing thermostats that are much nicer than these, right? Notice that they also offer something else. They offer this. Smoke detector. Do you know why? Because there's someone who cares. There's someone with an economic motive for you to have that in your house. The insurance. So you see today already that insurances are offering little smart home packages. And they're offering these smoke detectors, and they're offering them in a connected way. And that is because if you have a smoke detector, it's less likely that your house is going to burn down completely, and therefore the insurance has to go and cover it all completely. Telemetry in your car is driven by insurances. You can go and get these dongles in your car that are going to transmit the telemetry from your car to your insurance company, and the insurance company can go and take a look at how well you drive. And with that, they also hope that because you have that dongle, you're not going to drive like an ass and therefore cause more accidents. Here, they're really keen on the house not burning down. And what you'll see is that the Internet of Things is going to be very often driven by insurance companies, because the insurance companies are running a casino, and they're betting against things that are happening or not happening to you. And if they go and give you equipment, they subsidize equipment that you can put in your house that lowers the chances of your house burning down while keeping the premium stable, they're improving their odds and they're making more money, so they have an economic advantage, incentive to do this. So smart home is something that your insurance is going to be interested in. An alarm system is something your insurance is going to be interested in. So it's not necessarily comfort that drives that, but it's actually protection, again, safety, security that's driving that. It's driving the Internet of Things. So that's why smart home and comfort never shows up on my initial list. It shows up because there's got to be a driving economic motive for this, and safety, again, here is one. And then ultimately the driving motive for that is that the insurance, for instance, is interested in bettering their odds. And of course, also cities want to go and better their odds, and everybody wants to better the odds. And another thing is like flood management. It's also an insurance thing. So there's information services. You can go to Elbpegelstand. That's in the Elbe. It's a river in Germany, and there's a network of sensors that goes and tweets. So you can go there. It's a federal government service. The Americans have also real-time data of water flows and drought services, etc., at waterwatch at usgs.gov. There's obviously earthquake information service, which is really important if you are in California or also if you're Washington State on the West Coast. That's a place where it shakes very often, and you want to know how things are going, so that's all live. There's obviously traffic information. The Googles have that very well. The Bings have that also very well. Live traffic information. What's interesting about Google Maps is also how the data is being sourced. If you have an Android phone, you're contributing to that map. You don't have to go and look at the map per se, because every phone sends information periodically about where it is, etc. And so it's very easy to take all that movement data and then extrapolate that into that map. And there's some really cool stuff that's also based on sensor technology that's being networked. And one of those is lightningmaps.org. Does anybody know lightningmaps.org? A few. So let's take a look at that one. So this is a super, super cool thing. And luckily, there is now a live event in the Mediterranean. These are real-time lightning strikes. This is how when I'm at home, when I want to know what the weather is like and whether the Belgians or the Dutch are sending me bad weather again, because they always do. They're mean. This is the site that I look at. So there's sensors kind of all spread around the world, and it's a volunteer project. And they're triangulating all these lightning strikes, and the lightning strikes are very precise. And the interesting thing is these circles around it is the thunder. And the site is so good that you can go and predict, you can look at it, and it will say the thunder is going to come, and it actually does. It's astonishing. So this is a wonderful thing to play with, and it's another application of the Internet of Things. It's connected sensors. So lightningmaps.org is absolutely fantastic. And then obviously there's also Flight Radar 24 that you all may be familiar with. Gives you data about flights that are currently in the air. That is also fantastic. And then there's another site, Flight Aware, which is doing that also. So let's go and take a look at that. And let's take a look at my stats, because I have a feeder, I have an antenna on my house, and I'm collecting live data, and I'm feeding that both into Flight Radar and feeding it into Flight Aware. So I have a site myself, and so that's the stats for it. And so this is a collection graph. So I can see with my antenna about 180 to 200 miles out from my house, I can see the aircraft that are flying around. They're sending out digital packages. So every commercial aircraft is equipped with an ADS-B beacon, and they send out position data, they send out speed information, and position data also includes altitude, and so that's information that I'm getting here and that I'm feeding in, and I'm feeding about 300,000 events, and I see about 5,400 aircraft per day on my site, and that all goes into the common pool, which then produces the maps, for instance, on Flight Radar and on Flight Aware. I didn't put a link in there. Okay. So this is how that site looks, Flight Radar where you have the individual flights showing up. And then, of course, from that, you can derive all kinds of interesting data about air pollution, noise pollution, et cetera, et cetera. And the same thing, because you are all here by the sea, exists also for boats and ships. Marinetraffic.com is also a fantastic site to look at. And again, another application of the Internet of Things. There's beacons, people who are running those things, and you can see that data. So there is a lot of data out there. And what I showed you is all kinds of sites which are providing that information. And really, what we're going to go and build on top of this? That's the big question. The data exists. I showed you the city of Düsseldorf providing that information. We have information about air traffic. But it's all separate. What are we going to go and build? So what we have today is civilizatory infrastructure and the elements. And what I call digital infrastructure is stuff that's being built on top of it. We have a control layer, drivers, who can go and control things. We'll need this. We need to have a way to go and execute remote control on things that are out in the world. We need to do remote execution of actuators. We want to open, simple example, I want to open the door of a car with a smartphone because I don't have a key for that car because I'm doing a car rental service, as a car sharing service. So I walk up to a car that's being assigned to me, and so I just use my phone as the lock, as the key. Well, that can only work through infrastructure that sits somewhere in the cloud because the authorization gate sits in the car sharing system. I need to have historical records. We saw examples of that. I need to be able to go and analyze that. I need to have real-time information to have current information about those things, and I need to be able to go and score events based on prior events. I need to have machine learning kind of in this. And then we can go and build land, air, sea navigation, smart grid, smart city, public transportation management, logistics, etc. On top of that, you've seen some of those, and apps, things that interface with people, then go on top of this. This is digital infrastructure architecture. This is how we digitize our world, by taking the real world, putting a driver system basically on top of it, building platforms on top of it, and then build apps towards it. That's the big box architecture. So we're doing some part for that, but we also need to do standardization, not only on the technology side, but also on the provider side. This is Germany in 1648. And you'll notice that's not a very happy picture of unity, because these are all individual little states. And this is kind of the state of affairs in terms of public data that you can go and build on top of. Everybody has their own thing. And that's true in every single country. So we need to get to places where we can go and standardize how we think about public data that we get, and so that we can actually build meaningful applications on top of this. The stuff already exists, and there's a lot being built. It's not that we're at the beginning of the Internet of Things is going to be in the future. No, all that stuff is already there if you've seen it. But we need to work on standardization, not necessarily on standardization on foundational protocols. We're largely done with those, I think, personally. But we need to go and think about how we harmonize data. And the problem is standards will remain elusive for a long time, so we can't really standardize everything. Scalability is a big deal, right? We're collecting all that information from those public sources. Who pays the bill for all those things? Because the cities will collect the data, they have the data, but can they disseminate that data in that way, right? The city of Düsseldorf, can they actually build a platform that can withstand, I don't know, 1 million requests per hour? That's not even much, right? Can they? Who's going to pay for that? So we're going to get to a place where I think we're going to have companies which are going to go and do the standardization via their platform. There's a data middleman space that's kind of completely wide open, where because standardization is not going to happen, you're going to go and provide a platform for the entire country that provides information about current construction sites, right? Real-time enhancement for map data. And you're going to do that for profit. And then there's the question of scale, because the scale of all of this is really staggering if you think about traffic. Volkswagen, to name everybody's favorite company this week, puts 10 million vehicles on the street per year. 10 million vehicles is a lot. When we think about making all of those devices connected, that's pretty big systems. All of a sudden, you need to have a system that has 10 million devices, 10 million cars connected all the time. So when we talk about those cars in themselves are data centers. 40 microcontrollers at a minimum are living in one of those cars. Now, we think about other devices, stuff that goes into homes and all of our wearables that we're all going to have. We're talking about even bigger numbers, which need to be nailed up to those systems. Today, people who are building enterprise systems are proud if they build a system that scales to 50,000 users. With digital products, we are 2, 3, 4 orders of magnitudes above that if we're digitally enhancing the systems that we build. So, and also the data throughput numbers are just enormous, right? We're talking about gigabytes per second, petabytes of storage for those systems. So we're moving into hyperscale, and this is the time where you can go and plan those things on your own data center, or you can think of I'm going to build X servers to support my product. That's over. You can't do it because the scale is too high. So the only way you can get to that is public cloud. So for an IoT architecture, the requirements are that you have extreme hardware and software heterogeneity, low barriers to entry, support public, so you need to have support for all of those different models of cloud, and that you really need to build for hyperscale and for those kinds of scenarios. So we have a model for this, which is our reference architecture. And our reference architecture is an abstracted model of how we think about the world. There's IP-capable devices, so anything that can talk directly, and those IP-capable devices talk to what we call a gateway. That gateway can have multiple shapes. And then there's existing devices, there's low-power devices, which are then talking through a local gateway that's called the field gateway, which is going to do the translation of hooking up to the cloud. All of the cases that I talked about today are all cases that share a common thread, and that is local connectivity plays a role to go and make coordination, like the car that drove by itself, right? It has local sensors, it has a local processing capacity, but to make this thing real, to get to the 10-year vision of completely autonomous driving, it will have to talk to the rest of the world. All of those cases have in common that they need integration from that sensor which sits somewhere out in the world to a central place where that data can be evaluated. So they're all cloud scenarios. They're all data center scenarios. All of that coordination, all of the infrastructure stuff, digital infrastructure is all about data center. And it's all about often about data center where you can't predict the capacity that you need, so often those are cases for public cloud. So we know that the low power devices, the smallest and smallest of sensors, will not be able to build a reliable end-to-end IP connectivity to a cloud system, but a gateway will. So there's a place for fog, as it's called. There's devices which are kind of all the low power devices connect to, and then the fog kind of connects for them to the cloud systems. Or there's field gateways, like little boxes you have in your house that all your smart home devices go and connect to through protocols like Zigbee, and then your smart home gateway is going to take that role. So we're going to have a number of these models for how devices connect to that cloud gateway. And behind that cloud gateway is a hot path and a cold path of doing analytics. Cold path is stuff goes into storage. Hot path is we're reacting on data. We're writing programs to go and evaluate the information. And then on the right side of that, we go and visualize it out. Based on that foundational pattern, making this more concrete, we're now building things. So we have 4 devices from real-time OSs, Linux, Android, iOS, and Windows. We're building libraries that go and very nicely integrate with the IoT hub that lets you go and build applications for gateways and lets you build applications for devices that you can then hook up to infrastructure in the cloud gateway, either through event hubs, ingesting information into the cloud for evaluation, or through IoT Hub, which allows you bidirectional communication with those devices, including control. And then it has a broad number of options to go and do analytics out on the back. So you have for cold path analytic, you have HD Insight, Azure ML, Power BI, Data Factory. For hot path analytics, which means you do analytics in real time, you have Stream Analytics and Azure Storm. And then you can also do compute, hot path compute, do compute in the fire hose effectively with Service Fabric and the actor frameworks. And then, of course, we're hooking this all up with logic apps, etc., and BizTalk services into all the backend services that are needed. So we have this reference architecture to go, but it's a set of Lego bricks. We're not going to build. We're not giving you a single box, but we're giving you a set of Lego bricks. One of those Lego bricks is Event Hubs. Event Hubs lets you go and create a single thing that can take 1 million different sources, literally, up to a gigabyte per second of input, buffer that up, and then lets you consume that for analysis, for instance, in Stream Analytics, or just pull that into your own analytics systems. We're currently running 1.5 trillion, with a T, events per month through Event Hubs. It's a lot of stuff, right? That amounts to nearly 10 petabytes of data that runs through Event Hubs. IoT Hub is a new thing. We just announced that. And IoT Hub is like Event Hubs. It also talks to devices, but it's bidirectional. So it gives you the ability to go and stream data at that same scale. We're currently we're in public preview. We're allowing 1 million devices in public preview. We're going to allow more in the release, and it's giving you bidirectional connectivity into those devices. And you also can execute commands. We're also supporting field gateways and cloud gateways, and then you can go and hook that up to the rest of that architecture. And when I say millions and trillions and all those things, it's built to scale to those sorts of infrastructures, to those sorts of capacities. But if you're building your own projects with Raspberry Pis, it works for those too. We're really building for those large infrastructures that I just talked about. Hang on, I'm almost at the thank you slide. Let me just show you 2 more things. And that is, let me just try to get this up. This is fine. So this is the IoT suite, and the IoT suite is an so that sits on top of the IoT hub. The IoT suite is that reference architecture that I just illustrated implemented. So you can go to Azure IoT Suite.com, and you can go and create an IoT suite for you, IoT suite app, and we have a pre-configured application. That pre-configured application is an instance of this code. Actually, I have this loaded here already, I think. Yes. So Azure IoT remote monitoring. So one thing we're doing here, and that's very important, we can go and instantiate a effectively working application for you, which is a remote monitoring app for devices. At the same time, we're giving you the entire source code for it, so you can go and customize that thing. Because we don't believe we can build an app for everybody. So think of the Azure IoT Suite as a starter point, and if you want to do little customizations, you can go and use that. You can use it out of the box if you want to. But more likely, you're going to go and use that as a starting point to build your own products. And that's already using all of the different products. So it has hot path analytics, cold path analytics. It has the ingestion, identity management, and all those things in here. And you have a functioning example for this. And we're making that available, the solution, as a starting point on GitHub. The client libraries are also here. And they're available in C and C#, so you can go and embed that onto the tiniest devices. We have driver for ARM embed, and for a number of kinds of devices, all the source code is up here as well. And we have the protocol gateway. And if you have your own protocols today, and those protocols need to be attached to Event Hubs, and you don't have native support for those, you can go and very easily build support for those protocols onto the gateway, and we're happy to take contributions to that as well. We have an MQTT implementation here as an example. That's a production-ready MQTT implementation, for instance, and we're expecting that we're going to have more as part of this project. And with that, I'm out of time. I'm a minute over, sorry. And I hope that was informative. In the beginning with a few scenarios, motivating the Internet of Things and also showing that the Internet of Things is not something that's in the future, but it's already there. And the things that we're doing to help you build applications in the Internet of Things. Thank you for your attention. Have a great day.